Hey, it's Holly from the Science Hive. This is a video about states of matter and includes specification content for the iGCSE Edexcel syllabus for both double award and triple award students. So the vast majority of materials exist in one of three states: a solid, a liquid, or a gas. In reality, there are actually more than these, including the very exotic plasma state and superfluids. But at GCSE, we only need to concern ourselves with the run-of-the-mill solids, liquids, and gases. For the exam, you will need to be able to state the properties of each of these. So solids consist of particles which are tightly packed together in a regular arrangement. The particles are low in energy, which means they don't move around much. They vibrate in fixed positions, and there are strong intermolecular forces between the atoms which are holding them in place. Liquids consist of particles which are a little more spread out and more randomly arranged. There are weak intermolecular forces between the particles, and the particles have a medium amount of energy. This means that the particles stay fairly close together while still moving slowly past each other in all directions. Liquids can change shape and will assume the shape of whatever container is holding them. Gases have very weak intermolecular forces between the particles and lots of energy, causing them to fly around in all directions. The particles of a gas are far apart from each other, and they travel about in a straight line. Gases don't keep a definite shape or volume and will always fill any container that they are placed in. So the state that a substance is in depends on the amount of heat energy that it has. The more heat that is added to the substance, the more the particles are free to move, since some of the intermolecular forces that are holding them together start breaking. Once a certain temperature is reached, the particles will have enough energy to turn into a liquid in a process called melting. When even more heat is added, the liquid particles will have enough energy to become a gas in a process called evaporation. And then if we were to reduce the temperature, intermolecular forces between the particles would start to reform as heat energy is lost. The gas particles will convert back into a liquid, and that's called condensation. And if we reduce the temperature further, the liquid would become a solid in a process called freezing. Remember that if a solid is converted straight into a gas, this is referred to as sublimation. So we can prove that the particles of a liquid or a gas are free to move by carrying out certain experiments. The first, and you may have already done this in school, is to investigate the diffusion of potassium manganate through a beaker of water. We use potassium manganate because it has this deep purple colour, so we can see the particles easily. When we add it to a beaker of water, we'll see it spreading out into the solution until the whole contents of the beaker is a purple colour. This is because the random motion of the liquid particles causes the purple colour to be evenly spread out through the water. So that experiment proves that the particles of a liquid are constantly moving. Now how about gases? Well, to investigate how particles of a gas move, we can set up a tube containing two balls of cotton wool. One ball has been soaked in aqueous ammonia and the other has been soaked in hydrochloric acid. These balls of cotton wool will give off ammonia gas and hydrogen chloride gas. And what's going to happen is that these two gases will move through the tube until they meet each other. And at this point, they're going to react with each other to form ammonium chloride, which is a white solid. So we should see something that looks a bit like talcum powder appearing inside the tube. Now, ammonium chloride doesn't form right in the centre of the tube, but actually closer to the cotton ball containing hydrochloric acid. And that's because ammonia is much lighter than hydrochloric acid, so it can travel faster along the tube since it doesn't have to drag so much weight with it as it moves. Okay, so now we know exactly what we mean when we're talking about solids and liquids. But what about if I dissolve a solid into a liquid? Well, then we've got a solution, And if you're anything like me, you probably make them all the time without even realising it. So every time you add sugar to a cup of tea or coffee, you're forming a solution by dissolving the sugar into water. In chemistry, we call the substance that's being dissolved the solute, and the liquid that it's dissolving into is called the solvent. So in our example of the cup of tea, the sugar is the solute and the hot water is the solvent. Every solvent has a limit to how much it will dissolve, which we call its saturation point. So if I keep adding sugar to my cup of tea, I'll eventually exceed its saturation point and I'll have a saturated solution, where no more sugar will be able to dissolve. In the exam, you need to be able to define these key words. So a solution is a mixture of a solute and a solvent which does not separate out. A solute is the substance that's being dissolved, whereas the solvent is the liquid that it's dissolving into, and a saturated solution is a solution where the maximum amount of solute has been dissolved, so no more solute will dissolve in the solution. Okay, so if you're studying double award science, you can stop here. Everything else that I'm going to talk about in the remainder of this video is only relevant to those studying triple award. Okay, so now we're going to talk about solubility, which is the ability of a solute to dissolve in a solvent. It is measured in grams per 100 grams of solvent. So for example, the solubility of lead nitrate is 54 grams per 100 grams of water, whereas the solubility of sodium chloride is 36 grams per 100 grams of water at 20 degrees. This means that if I have a beaker containing 100 grams of water, and that's the same as 100 centimetres cubed of water, then I can dissolve 54 grams of lead nitrate or 36 grams of sodium chloride before the water will reach its saturation point, and at that point I won't be able to dissolve anymore. We can show the solubilities of different substances using a solubility curve, with temperature plotted on the x-axis and solubility plotted on the y-axis. We can look at these solubility curves to see the solubility of a substance at a particular temperature. So for example, looking at this solubility curve here, we can see that at low temperatures, sodium nitrate, NaNO3, is the most soluble, whereas potassium chlorate, KClO3, is the least soluble. Okay, and that's everything. I hope you enjoyed the video. Please comment if you have any questions and subscribe to our YouTube channel. If you haven't already visited our website, please do. All of the information in this video is explained in detail on our website, and you can download a free revision worksheet. You can also follow us on Instagram, Facebook and Twitter. Thanks for watching.